In this video, we are going to continue with the quotient rule. You will find this on page 478 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. We are going to look at a more practical example, application. Find the x-coordinates of the stationary points of the curve this. Okay, so I must use the quotient rule. But can you remember stationary points? The stationary points is where the gradient will be equal to 0. Again, if you cannot recall it, go back to chapter 6. First revise that applications of differentiations and then try to go on with this example. Okay, so we must first differentiate. So rewrite the denominator, differentiate the numerator, rewrite the numerator, differentiate the denominator, and square the denominator. Okay, so now it's the derivative function. And at the stationary points, the derivative function will always be 0. Why is that? Because that is a stationary, that's a turning point. And if you look at the gradient at a turning point, what is the gradient? I'm too low. No, I'm too high. The gradient at a turning point, and again, is always going to be 0. Okay, and that's why I put a 0 in the place of dy over dx. And then I'm just, now if you struggle to see this, put it over 1. Then you see if I multiply that will, but if I multiply with 0, this will disappear, the denominator. And there I showed it to you. Okay, and then I just take out the common factor. So x, it will be 2 points, where x is 0 and where x is equal to negative 2. Okay, I'm going to give you a little bit more here. The reason why is because everyone is a little bit different. And I want you to practice a few of this using the quotient rule. So definitely number 1, because it's stationary points. And then I want to give you number 2 and 3. And the reason why, I want to see if you see the difference between these two sums, that you don't get confused between these methods. And then, because we didn't do a normal yet, I thought let's also do number 5. Again, stop the video, and as soon as you're done, you can continue the video. Otherwise, do 1, continue, do 2, continue, stop, something like that. Something that works for you. Okay, number 1. Find the x-coordinates of the stationary points of the curve. Now, it's more or less exactly the same. Now, in this case, they didn't do it, but they could have right here, where, and what will I write here? And I'm going to leave it out. Why am I writing this? Because as soon as it's 3, then it's going to be 3 minus 3, which will lead to division by 0, which is undefined. And that's why they are putting that sentence. It's actually not going to affect the sum at all. It's just correct to name it. And sometimes they name it and sometimes not. So if I want to name something here, I say where x is not equal, and what can x not be equal there? Negative 1. Do you agree? Because as soon as x is negative 1, it will become 0. So you just look for a value that will lead to 0, and then you say, and you put a line through it. That means where x is not equal to negative 1. Okay, so don't let it confuse you in a test. So I'm going to start. This is more or less exactly the same. So the first thing that I'm going to do is I'm going to differentiate. And how am I going to differentiate? So if I'm going to say dy by dx, I rewrite the denominator. Okay, always start with the denominator. I differentiate the numerator. So that's very nice. It's no brackets, very basic ones. Minus 2, that becomes 0. Subtract the quotient rule. I rewrite the numerator. And I differentiate the denominator. And I put it over, and I take x minus 3 and I square it. Okay, now I can basically just simplify. So if I multiply out, I'm going to get 2x squared minus 2x minus 6x plus 6. This is just 1, so it's nice. Just bring that negative in. Plus 2x minus 1. That is going to be over x minus 3 squared. And now it's just my like terms. So like, like, and this is the same. Okay. So I'm going to end up with 2x. So it's just going to be, let's just see if I have white. It's going to be x squared. And this is going to be, this 2 cancel out, do you see? So it's going to be negative 6x. 6 minus 1, and that's going to be 5. And leave it like this. X minus 3 squared. Now, don't forget, and I like to write it always in here as well. So 4 stationary points dy by dx is equal to 0. So I put a 0 in there. And again, don't forget, and I'm going to show it again to you. This is over 1. So if I cross multiply, this denominator will disappear. So I'm just going to end up with x squared minus 6x plus 5 equals 0. Okay, and now I just factorize, and if I factorize, this is going to be 5 and 1 and 1 and 1 and 5 plus 1, because it's in group A, so I must add, it's 6, and the signs will be the same. So it's going to be x minus 5, x minus 1 equals 0. So therefore, x is equal to 5, or x is equal to 1. And that is my final answer. That is my final answer. Question was, find the x coordinates of the stationary points. Okay, that's number 1. Let's do number 2. A curve has equation, and I always write first the function down. Find the coordinates of the points on the curve at which the gradient is negative 4. So again, I'm going to differentiate, and I'll show you now where it's actually just different places where you substitute, and that's why I gave you both. But it's again the quotient rule. So if we start, let's first differentiate. Rewrite the denominator, differentiate the numerator. Subtract, quotient rule. Rewrite the numerator, differentiate the denominator. Over. Okay, I can simplify it just because it's very easy. So it's going to be 3x minus 15. This is minus 3x minus 1. And that is going to give me over just at least that little bit. So this is cancelling, do you see? So it's negative 16 over x minus 5 squared. Okay, now this is very important. If they give you the gradient, don't forget that, and I'm going to make it red, this represents the gradient. Okay, so then I substitute in the place of dy dx. Okay, so then I'm going to say when, that's correct, when gradient is negative 4, that means dy by dx will be equal to negative 4. You substitute in there, not in the place of x, in the place of dy by dx. So that will give me then, if I substitute, so it's going to be negative 4. Definitely it's not a stationary point. Stationary point, I put 0. negative 16 over x minus 5 squared. Put it over 1. One term equals one term. I always cross multiply. So it's negative 16, negative 4, x minus 5 squared. Okay, and if I simplify this, negative 16, and I'm just going to, and I'm doing the short way, I square the first term, I multiply, and I multiply by 2. The 2 with each other, so it's negative 5x, so it's going to be negative 10x. Square the last term, 25. And that is just going to give me negative 16 equals negative 4x squared plus 40x and minus 100. And if I take it over, I'm going to get negative 4x squared. I can now make it positive. Plus 40x. And if I subtract that 2, I'm going to get negative 84. Okay, that was a negative. That was 40. If I want to factorize, I don't like that first one, and it's an equation. So basically, I can either say I just multiply with negative 1, or I divide, or I take the terms over. But at the end, I think I'm going to just take it over. Because I want the 0 on that side. Okay, and now I'm going to simplify it first, because then it's easier. So divide 4, so divide that. I always like to bring that in, so divide 4. Then I'm going to have x squared minus 10x plus 21. Oh, and now it's easy to factorize, because now I can just basically say 7 times 3, it's again group A, 1 and 1, 7 plus 3 is 10. Signs are the same, but both is a negative. So it's going to give me x minus 7, x minus 3 equals 0. So therefore, and I'm going to make it in red, x is equal to 7 or x is equal to 3. Okay, so find the coordinates at where the curve. So at this point, the gradient will be negative 4. Okay, but now I want to show you why I gave you number 3. So let's just go back. And I'm going to give you number 3. See, I didn't write there trinomial 9, but I think you know it's trinomial 9. Just want to get this 9 away. I'll come now back. Okay. Just let's make space. And don't forget, we are busy with trinomial 9. And we are going to do number 3. Okay, so find the value of dy for this when x is 4. Now, this is not the gradient. This is the coordinate points, but I don't need to find the y. I only find the y if they talk about tangents or normals. Then I will find the value of the y coordinate. But in this case, it's not necessary. So I'm just going to start with the function as always. And then I'm going to differentiate, as always. Okay, let's start again. Rewrite the denominator. So just remember, rewrite denominator. Differentiate numerator. Subtract quotient rule. Rewrite the numerator. Differentiate the denominator. And denominator square. So learn that rules. It's very important. So x plus 1 minus x plus 1 over x plus 1 squared. So x minus it cancel, and it's going to be 2 over x plus 1 squared. Okay, Now, you don't substitute. You substitute in the place of x. So that's why I say when, not the gradient, when x is 4, then I can say dy by dx equals, and now I just substitute 4 in the place of x. And that will give me 2, and 5 times 5 is 25. And that's the answer. So find the value. So that is the value of dy by dx. It's 2 out of 25. It's actually easier, so can you see that? Then the final one. Let's do the final one. It's all applications, and you will find all these basic methods in chapter 6, where it's the basic differentiation. Here we are just bringing more difficult rules in. Okay, number 5. Find the equation of the normal to the curve at the point where the curve cuts the x-axis. Now, I think it's always good. Okay, let's first write the function. I always like starting with the function. But before we differentiate, let's first find that coordinate point because we need it now, because it's the equation of the normal. Now, how do we find that? Where the curve cuts the x-axis, y will be equal to 0. So I'm going to say, okay, I like to use 4x intercept is always the opposite one that's 0. So that means I'm going to put a 0 in there. I didn't differentiate, I'm just trying to find the point. And again, I want to show you, if you put this over 1 and you cross multiply, then this will be left, x minus 2, and this will become 0. So therefore, x will be equal to 2. But don't forget, what was the value of y? 0. So what is your point? So therefore, the point is 2 and 0. Keep it in mind. That's the point what you're going to work with. Now I want to find the gradient. So now I'm going to differentiate. So now I'm going to say dy by dx. Okay, how do I always start? Rewrite the denominator. Differentiate the numerator. Subtract. Rewrite the numerator. Differentiate the denominator. And then it's going to be 2x plus 1 squared. And I want to simplify. So it's going to be 2x plus 1. Okay, now be careful. It's almost like that negative 2 is standing there. I don't want to because you cannot scratch. So if I'm saying, and if you think you're going to get confused, you can maybe just quickly say there, it's going to be negative 2. You can even just rewrite it there on the side. Then you will not make a mistake. So please don't make a mistake there, because it's going to be negative 2x, it stands there, but the negative times a negative, do you see that negative, it's going to be positive 4. That's going to be over 2x plus 1 squared. And if I simplify, this cancel, and then this is going to be 5. Let's just finish this. 5 over 2x plus 1. That is, and don't forget your square. So easy to forget that. And move up. Oh, that is still from the previous sum. I have to clean this. Okay, so basically I'm going to find the gradient of the normal. Now I want to show you the gradient. I must substitute the x value in. Now what is the x value? It's 2. So I say when x is 2, then dy by dx will be 5, 2, and let's just put a bracket, plus 1 squared, and that's going to be 5 over, this is 5 squared over 100. So that is going to be, let's just see if I'm correct. No, not over 100, I'm a bit too much. Because this is 2 plus 1, it's 5. And 5 times 5 is just 25. Oh, okay. And that's going to be 1 over 5. But that is the gradient of the tangent. If I want the normal, I must take the reciprocal. Now, I want to show you this, and this is very important, that you don't have to turn it around. The formula, this formula will turn it automatically around and bring the negative. And I'm going to show it to you in this video. So the gradient, so the equation, let's start. Equation of normal where m equals 1 over 5 at the point. And what is that point? Let's just write that point down. Can you remember? At 2, 0. So don't forget that this is m. This is x1, this is y1, and this is m. So if you use that formula, if you're going to say the equation, and I just want color, I will go for blue. So y minus y1, this is for normal. You don't have to turn it around. This formula will turn it automatically around. X minus x1. So basically, I'm going to say, then don't forget this is y. So as I said, this is x1, y1. So it's going to be y minus y1, 0. And now look, it's turning it around. Okay, now it's a bit more challenging if I'm writing it's 1 over 5. But if it's turning, it's going to become negative 5. And if you take here the reciprocal, if you turn it around, the reciprocal, it's going to be the negative, and it's going to be fine, the perpendicular one. Okay, but I will now do it. So x minus 2. And then if I simplify that, it's going to be y. This is just going to become negative 5. Don't let it confuse you. I just didn't turn it around there because the formula turns it around and changes the sign. So then y is equal to negative 5x plus 10. And just for the video's sake, I'm just going to end up very nicely. And I'm going to say, therefore, I want to change colors. Therefore, equation of tangent is y equals negative 5x plus 10. And that is your final answer.